In this video, we're going to discuss the binary search algorithm, which is much more efficient than the linear search algorithm, which is discussed in the first part of Chapter 8. The linear search algorithm is inefficient because it simply looks at each element of the array from the beginning to the end until it locates the value that it's looking for. If the value that is being searched for happens to be in the last element of the array, the linear search algorithm has to examine each element to locate that value. Also, if the value that you're looking for does not appear in the array, the linear search still has to examine every element of the array in order to determine that the value was not found. The linear search algorithm is okay to use when you're searching a small number of values, but if you're searching a large array that contains a large number of values, then the linear search algorithm is just too inefficient. Instead, you should use the binary search algorithm. Let's look at how the binary search algorithm works. First, it requires that the data in the array be sorted in ascending order. Like the one shown on the screen, the data needs to be sorted from lowest to highest. When the algorithm begins its search, rather than starting with the first element in the array, the binary search algorithm starts with the element that is in the middle of the array. In the example shown on the screen, that would be the element at subscript 4. If the value that we are looking for happens to be in the middle element of the array, then the search algorithm is finished. But what if it's not found in the middle of the array? Well, if the value we're looking for is greater than the value in the middle element, then we know it will be located somewhere in the upper half of the array, if it's in the array at all. If it's less than the value in the middle element, then we know that it will be located somewhere in the lower half of the array, if it's located in the array at all. So the algorithm goes to one of the two halves and the process starts over again. If the element in the middle doesn't contain the value being searched for, then this part of the array is divided in half and the algorithm goes to one of the two halves and starts over. This process continues until there are no more elements to search or the value is found. In this algorithm, we will be repeatedly calculating the position of the element in the middle of the part of the array that we're searching. So let's talk briefly about how we're going to do that. Quite simply, we take the subscript of the first element in the part of the array that we're searching. We add that value to the subscript of the last element. So if we're going to search the entire array, this would be 0 plus 8. And then we divide that sum by 2. And in this case, it gives us 4. So 4 is the subscript of the element in the middle of the array. When we are searching only part of the array, we follow this same procedure. For example, suppose we're searching the upper half of the array. Well, this array goes from subscript 5 up through subscript 8. So we take the subscript of the first element, 5, and we add that to the subscript of the last element, 8, and that gives us the value 13. Well, we then take this value and we divide by 2. Now, conventionally, 13 divided by 2 is 6.5. But when we write this math statement in our program, we're going to use integer division. So rather than getting 6.5, we'll get 6. So this will tell us that subscript 6 is the element in the middle of this part of the array. Before we look at any of the actual code for the binary search algorithm, let's step through the process that it would take if we were searching for the value 40 in this particular array. First, the algorithm looks at the element in the middle of the array, element 4, and determines that this is not the value we're searching for. The value that we are searching for is greater than this element, so it's going to be somewhere in the upper part of the array. The element in the middle of this part of the array is at subscript 6. And once again, this is not the value we're looking for. The value we are looking for is greater than this value, so it's going to be somewhere in this part of the array. We calculate the position of the element in the middle of this part of the array, and we get element 7. Well, that happens to be the value that we're looking for. So the binary search algorithm located the value 40 in only 3 steps. If we had used the linear search algorithm, it would have taken 1, 2, 3, 4, 5, 6, 7, 8 steps. This is the code for the binary search function that is shown in Chapter 8 of your textbook. The way that it works is that you pass an integer array as an argument. Now, you could rewrite the function to accept any type of array, but this example takes an integer array. The second argument is the size of the array, the number of elements. The third argument is the value that you are searching for. The function will return an integer that will either be the subscript of the element holding the value if the value was found. If the value was not found, the function returns -1. Let's look at the local variables. There is a variable named first and a variable named last. These variables will hold the subscripts of the first and last elements in the part of the array that we are searching. When the function is first called, we want to search the entire array, 0 through the last element of the array. So we initialize first with 0, and we initialize last with size -1. The middle variable will hold the subscript of the element in the middle of the part of the array we're searching, and the position variable, we initialize that at -1. When we find the value that we are looking for, we will store the subscript of that value in the position variable. Finally, there is a Boolean variable named found, which we initialize with the value false. When we find the value in the array, we will set this variable to true. If we never find the value, then it will keep the value false. So let's say that this array that I've sketched out, this is the array that I've passed to the function. After we've defined the local variables, the first variable will be set to 0, and so it marks the first element in the part of the array that we're searching. The last variable will be set to 8, and it marks the last element in the part of the array that we are searching. The while loop will iterate as long as found is not true, in other words, as long as we have not found the value in the array, and as long as first is less than or equal to last. If first is less than or equal to last, it means that there's still part of the array that hasn't been searched. Inside the loop, the first thing that we do is that we calculate the midpoint of the array, and we use the math formula that we talked about earlier to do that. So the middle variable then marks the midpoint of the array. Then we examine the value at the midpoint of the array. If array submiddle is equal to the value that we are looking for, then we've found the value. If that's the case, then we set the found variable to true, and we save the position of the value in the position variable. However, if we did not find the value at the midpoint of the array, then we do another comparison. If the value at the midpoint of the array is greater than the value we're looking for, then we know that the value that we are looking for is going to be found somewhere in the lower half of the array. Now, if that's the case, we want to change the value of the last variable. We want the last variable to mark this location rather than the last element in the array. So that's what the next statement does. It says last equal middle -1. Otherwise, if the value that we are looking for is going to be found in the upper half of the array, then we want the first variable to mark this location, and we would leave the last variable where it was. Well, that's what happens in the else clause here. It assigns first to middle +1. When the loop finally finishes executing, the function returns the value in the position variable, and that variable will hold either a -1, which indicates that we never found the value in the array, or it will hold the subscript of the value.